Spice math. That's right. We add it up, multiply it, man. Spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Dottin.
Hi, I'm Erin Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Dottin.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hi, and welcome to another episode of Spice Math. In today's episode, we are going to continue our lesson on finding LCM. In our last lesson on LCM, we have looked at two methods for finding the LCM. I did say there were other methods, and now today we are going to look at another two. The objectives for today's lesson. At the end of today's lesson, you should be able to find the LCM of two numbers using the grid method. You should also be able to find the LCM of two numbers using Euclid's algorithm. And you should also understand the vocabulary of division. The tools you would need for today's lesson are a ruler, pencil, pen, and of course, something to write on, preferably a notebook. So just for review, I would go through what the lowest common multiple is and explain how we find lowest common multiples generally. So a multiple is the result of multiplying numbers by an integer. And we also said the lowest common multiple of a group of numbers is the smallest number that is a multiple of all the numbers. To identify the LCM of a group of numbers, we should be able to identify the factors of these numbers. There are a few methods that we can use, and today we are going to look at two more of these methods in addition to the two methods that we looked at in an earlier lesson. Our two methods for today's lesson are the grid or ladder method and Euclid's algorithm. So let's get into the lesson. For the grid or ladder method, step one, I'm going to draw a grid looking somewhat like a tic-tac-toe. So 2 lines down. So we have 3 columns and 3 rows. We're going to write the first number in the top center square of the column, which is usually this column, and the second number to the right. For example, if I want to find the LCM of 18 and 30, I'm going to put first number 18, this column, and 30, this column. Step 2. Look for a factor that is common to both numbers. So what is a factor? A number that can divide into these numbers without leaving a remainder. In this case, my factor would be 2. Because 2 could go into 18 and 2 can go into 30. So I put my 2 to the far left column to the top. It's always advisable to use prime factors, but it's not necessary to do so. I prefer to use the lowest prime factor to start with, and in that case, it's 2. So I now say 2 into 18, 9, 2 into 30, 15. And then look again, step 3. So I divide the factor into each number, and I have my answer, 9 and 15. So the quotient of 2 into 18 is 9. That's the answer when you divide. So my divisor is 2, my dividend is 18, my quotient is 9. There's no remainder. 2 into 30, my divisor again is 2, my dividend is 30, my quotient is 15. So let's proceed. We now look for another factor. The other lowest factor that can go into 9 and 15 is 3. So for our next step, we are going to find, we already found the factor, which is 3. And now we are going to divide the two numbers into using the 3. So 3 into 9 goes 3 times, and 3 into 15 goes 5 times. Now what we have here is 2 prime factors, and we basically can't divide anymore. So in effect, we can circle So our next step is to circle the prime factors and then write a multiplication sentence. However, if the question wasn't terminated here, we could have extended our grid. However, we finish here, so we'd continue. Our next step, as we said, I would have circled the prime factors and I would have written out the multiplication sentence. And we can see 2 by 3 is 6, 6 by 3 is 18, 18 by 5 should give you 90. So the LCM of 18 and 30, or the lowest common multiple of 18 and 30, is 90. Now I've placed some on the screen, and you should try them. So find the LCM of the following set of numbers using the grid method. Now, for our second method, we call it the Euclid's division algorithm. But before we get into that, let us revise the vocabulary of division. The dividend is the number being divided. The divisor is the number the dividend is being divided by. The quotient is the answer to the division problem. And the remainder is the amount left after a number is divided by another. So example, if I divide 15 by 6, I would get 6 into 15, 2, because 6 2s equal 12. So my quotient is 2 and my remainder is 3. So here we have a divisor. Here we have a dividend. Here we have our quotient. And here we have our remainder. So we can now set up this formula where the formula is the dividend is equal divisor times quotient plus the remainder. So what we had initially, 15 divided by 6 is equal to 2, remainder 3. Now I can write same using this formula. 15 is equal to 6 multiplied by 2 plus 3. So we're going to use this form to set up Euclid's algorithm to find the greatest common divisor of two numbers. Remember, the greatest common divisor is the largest divisor or factor that two numbers share. So in this method that we're going to use now, you first find the greatest common divisor and use the greatest common divisor to find the least common multiple. So let's get into an example. So in step 1, you use the larger of the two numbers as the dividend. You also use the small of the two numbers as the divisor. You're going to set up the equation in a quotient remainder form for these two numbers. For example, let's find the LCM of 210 and 45. As we can see, they're two pretty big numbers. And it may be a little long trying to use some of the other methods that we've used so far in the past. So we're going to write it with 210 as a dividend, divided by 45 as my divisor, and that would give me a quotient of 4 remainder 30. Because 45 into 210 will give you 4, and have a remainder of 30. Now I'm going to write this equation like this. 210 is equal to 45 multiplied by 4 plus 30. Take a look at it and I hope you understand. Now, we're going to use the original divisor, which in our case is 45, as the new dividend, and the remainder as the new divisor. So what does that mean? We are now going to say 45 divided by 30, and that would be equal to 1 plus a remainder of 15. So we can now write this as 45 is equal to 30 times 1 plus 15. So now we are going to now use our new dividend is now 30, which was the original divisor, and our new divisor is now 15. Now we are going to repeat this process until our remainder is 0. So we're now going to say 30 divided by 15 is equal to 2 remainder 0. So if you write this, you can write this as 30 is equal to 15 times 2 plus 0. So now that the remainder is 0, we can stop here. And we have basically found our highest common factor. Since the remainder is 0, our highest common factor is 15. So we now going to take what is our last denominator, and as we said, you can call it two things: highest common factor or you can call it the greatest common divisor. So it's basically the highest factor that can divide into 210 and 45 without leaving a remainder. So our last equation, we had 30 equal to 15 multiplied by 2 plus 0. Our remainder is 0. This last divisor or factor, 15, is our HCF, or greatest common divisor. So the greatest common divisor of 210 and 45 is 15. Now we can go to our next step. What we can do now to find the LCM is multiply 210 times 45. That gives us 9,450. Once we've done that, we are now going to divide by the greatest common divisor or the highest common factor. So we're going to divide 9,450 by, what was the highest common factor? Yes, 15. And our answer for this is 630. So now we have found the LCM of 210 and 45. The LCM of 210 and 45 is equal to 630. This method, as I said earlier, can be used for bigger numbers, and for students who are in secondary school, it's a really quick way to find the LCM of numbers that are greater than 100. There are some questions on the screen that you can now attempt on your own. Take some time to write them down. Thank you for joining us for another episode of Spice Math. See you again soon. Enjoy.